All right, so there's keywords here that tell you which one you're going to be writing. Okay, one of them is maximum and minimum, and that will tell you that it's an absolute value equation, okay, which means with an equal sign. Okay. Other times, the keyword will literally tell you, because the question is telling you, write and solve an inequality, which means write or solve an inequality. Okay, so you have to write an inequality, it won't be an equation. Okay, so let's take a look here. Since we're writing absolute value equations, let's just say that the title isn't there and you just see the problem. Right? You see the problem and you don't know, like, is it going to be compound? Is it going to be multivariable? Is it going to be one variable? Now I have all these things to consider. Right? All right, so let's find some key clues here that can help us out. So I have members of a track team that can run 400 meters in an average time of 58.2 seconds. Okay, so that's like running a full lap around the track in under a minute. The fastest and slowest time is varied from the average of 6.4 seconds. Okay, what were the maximum and minimum times for the team? Okay, now think about it, right? The average time is 58.2, and the fastest and slowest times varied from the average of 6.4 seconds, which means it could be like 6.4 seconds faster than that or 6.4 seconds slower than that. Okay, so in this case, right? Because I see that I have like a given number, and then it's just gonna like move slightly to one side or slightly to the other. That becomes absolute value. That becomes an equation, an inequality, because remember it's like a distance. If it's 0, you can be 7 steps this way or 7 steps that way. It's the same thing with time. 58.2 seconds, I can be 6.4 seconds faster or 6.4 seconds slower. Okay, so that's really all it is. If you can see the number line, where I'm at, and I'm on either 7 steps this way or 7 steps that way, that becomes absolute value, right? So here we go. Let's set this up. I have an absolute value here that I want to draw. Okay. Inside of the absolute value is where the variable goes. Okay, so you won't stick any absolute value. Any variables outside of the absolute value. Okay, so generally, and this is kind of why I said it's a little bit easy once you pick up the pattern. X goes inside, usually in the front. Okay. The value that we're talking about, okay, what was the average time? Is 58.2. Okay, that's the time that you generally want to keep in the middle. Okay, it's like a sandwich. You want that in the middle. Okay, and then the other things are the ones that tell you like how far to go on one side or the other. Okay, so then usually what happens here is the 58.2 goes inside. Okay, now does it say? Oh wait, well in this case, because we're saying that it's a maximum and a minimum speed, I don't want to know the gap, right? I don't care to know that if it was within the minimum or within the maximum. It's just like what's the minimum or what's the maximum of what it could have been. Okay, so since that tells me right there, that's a clue that tells me this is an equal sign right there. So the distance, right? What we're saying is the distance around this, right, is going to be what? The 6.4. Now the only thing then becomes, well, what symbol goes in between the x and the 58.2? Okay, so here's where you got to think a little bit here. Because let's say with an absolute value equation, normally you would split this up. Would it be okay to have negative time? No. So generally you're going to want to add 58.2 to this value. And remember that when you split it up, this becomes equal to negative 6.4. So you're going to take negative 6.4 and then you would add 58.2. So it wouldn't make sense for it to look like this. Okay, don't write this down. I'm just going to show you why it doesn't make sense. Because if you were to then split this up, you would get x plus 58.2 equals 6.4. And you would then also get x plus 58.2 equals negative 6.4. What would you have to do to 58.2 on both sides? Subtract. And then what do you get for both answers? Negative time. And that makes no sense, right? So then, what is the alternative? Instead of writing it as x plus, x minus. So you have x minus 58.2, x minus 58.2, okay? And then this is what we remember. If it equals 6.4, then you split it into two equations, one positive, one negative. Okay? And then from there, we will be able to find what was the maximum time, okay? Or basically like the slowest person, and then the minimum. Okay, let me zoom in a little bit. Let me make this fit in one box. Okay, so let's find those times. Let's find the fastest person and the slowest person that then gave us an average of 58.2. Okay, so we add 58.2 to both sides. X equals, that's going to be, let's see, 0.6, 64.6. Yeah, okay. All right. And then in the other case, we still add the 58.2. And X equals, in this case, yeah, you just take 58.2, subtract 6.4. That's going to be 51.8. Yes? Is that what you guys got? Yeah? Okay. So remember that when you're running, it's better to be a smaller number because that means you ran faster, right? So in this case, I guess the minimum time was this one, right? That's the fastest. And then this would be considered the maximum time, that's the slowest. Okay, so how they got the average? Well, they probably added them up and then divided by 2, and that's how we arrived at the 58.2. Okay. All right. So that's not too bad, right? It's the pattern is pretty simple usually. It's you have absolute value, you're gonna have x inside. Most of the time, this will be minus. Okay. With whatever value was where you're moving from, which tends to be right the average time or whatever, and then the value that you can be away from it is what's on the outside. Okay. All right. Let's take a look at number 2. Any questions so far? No. All right. So here we have another scenario. Okay. Ashley tosses a horseshoe at a stake 25 feet away. Right. So it's that horseshoe, metal horseshoe. You throw it, try to land it in the stick. Okay. I've never actually played it. I played cornhole. You toss the beanbag. All right. So it's 25 feet away. The horseshoe lands no more than 2 feet from the stake. Okay. No more than 2 feet. All right. So you're starting to get some clues there, right? The no more than, that usually indicates what? Yeah, kind of like an inequality, right? So it's an inequality here, not so much just an equal sign, right? So it lands no more than 2 feet away from the stake. Write an absolute value inequality, right? So we're giving you a hint there by telling you what you need to write. Absolute value inequality that represents the range of distances. Range, that's another keyword. Okay, so all of these terms right here, the range of distance. Notice how this didn't tell me I want the range of the minimum and maximum times. There was no range there. I just wanted the slowest and the fastest, the maximum and the minimum. In number 2, when it says I want a range, now you're thinking of it has to be an inequality. Okay, so range. Okay, just in case the question doesn't tell you what to create, if you see range, it's going to be an inequality for the most part. All right. Okay, so write an inequality that represents the range of distances that the horseshoe traveled. Solve the inequality. Write a sentence for your final answer. All right, so we know it's absolute value inequality. I need an absolute value. Okay. My x value, what should my x represent in this case? What is it that they're asking us to look for? It's kind of highlighted. Range of distances in what? Feet? Okay, so range of distances in feet. Okay, so now I know that's what my x is going to represent. Okay, what is the ultimate goal? How far were we trying to get it? What's the toss? What's the distance? 25. It's 25 feet. Okay, and then the other value that we have is that it lands no more than 2 feet away from the stake. Okay, so remember that the value that goes inside of the absolute value is kind of like, that tends to be like the middle spot. And everything else, what goes on the outside, is like how far it can be away from it. So then are we going to have 25 go on the inside or the outside? 25 would go inside. Yeah, so we have inside 25. Okay? All right. Now, I know that then 2 feet has to go on the outside. And now I need to set up what kind of inequality can it be. Because remember that I want my distance, remember distance, to be no more than 2 feet. So do I want my distance to be less than 2 feet, greater than 2 feet? It should be less than, yeah. Because if it was like greater than, then you're telling me I could toss this thing like 40 feet and that would be okay. Like, that's not right. So I want the distance away from the stake to be less than 2 feet. Can it be 2 feet?
No,
Why not?
because it can't land no more than, and horseshoe lands no more than 2 feet from the stake.
So no more than 2. So it
So
could be exactly 2 feet away. Yeah. Right. So the no more than, right, that represents like it's okay if it lands at the 2 feet mark. All right. 2 feet away or 2 feet before it. All right. And then what usually do we get here? It's a minus. Okay. And let's see if that makes some sense. All right. You know that you got the minus or the plus wrong because the answer won't really make much sense at the end. You get negative feet or negative time, negative distance. Something went wrong, and that's probably right. You may have put a plus here instead of a minus. Okay. So now, because of the way that the inequality is pointing, what do we turn that into? And problem. Okay, not or. And problem, that means we make what? Sandwich. Okay, so x minus 25 is less than or equal to 2, but greater than or equal to what? Negative 2. Okay, so right now it looks funky because we have like a negative 2. Does that mean like negative distance? Just wait till you actually add the 25 to both sides, and then you'll see like where x was allowed to land. Right? So we add 25 to both, all three sides. And here's what we get. 23, x is greater than or equal to 23, less than or equal to 27. Does that make sense to you? Right? If the stake was 25 feet away, and the horseshoe can land no more than 2 feet from the stake, well, it was either 2 feet, yeah, forward or backwards. So if you threw it 23 feet, well, that was 2 feet short. If you threw it 27, then you went 2 feet too far. And you could have landed anywhere in between, right? As long as you were within 2 feet. Okay. So the most important thing here is like when you write it, the answer will tell you if you wrote it correctly. It's almost backwards. Because if this ended up being something else, like 15 and 17, then it's like what that I'm way too far. Like that's not within 2 feet of my goal. Okay, does that make sense? Right. So the answer you have to pay attention to what it means. Like please do not just like get an answer and then just like circle it or box it and be like I'm done. Doesn't make sense with what we're asking. Okay, that's the most important thing. Okay, if it doesn't, then it's maybe the setup was wrong. Okay, or especially if you wrote it as an or problem, right? And then you ended up with like x is less than 23 or greater than 27. Well, then it doesn't make sense either. Okay, all right. Okay, I'm not gonna go over like the shading and the bracket stuff. We know how to do that. Okay, but if that's what I'm asking for, I'll tell you on the problem. Okay. Okay, let's try this one out. Okay, I'm not gonna do anything until you guys tell me to do it. So read it and tell me what I need to do first. All right, talk to me. What do you think I should do first? I have a word problem. What do I always need? Yep. What's the variable? X. What do you want X to represent? What are we looking for? Yeah, so it could be possible amounts. I'm gonna put $. Possible amounts of money Blake can have. Okay. The keyword possible amounts tells you what? It's some kind of range, right? It could be somewhere in between. Okay. So then that fact that it's a range tells you what? Means it's also an inequality, right? So like I said, what if I did not tell you this piece right here? You have to be able to find the key words that would help you write something, whether equation or inequality. Okay, now that we have this set up, okay, what should I write? How should I write it? Absolute value, x inside, okay, minus 15, greater than or equal to 5, less than or equal to, okay, okay. Why'd you have me change it? Ah, very good. Okay, so at most, right, it can be kind of tricky because you see more, or you see the word most, and you want to think, okay, more than, and you want to put the more than inequality or greater than, but in this case, it can't vary by more than 5. Like at most, $5 is the biggest difference we could have. Okay, so now, in your head, you kind of already know what these two answers are. If she has 15 and his money varies by 5, what's the lowest he could have? If she has, you have $15. I tell you, either I have 5 more or 5 less than you. What do I have? 10 or 20. I could have 5 more than you or 5 less than you, right? You kind of already have the answers in your head. You already kind of have an idea. So whatever you think the two answers are going to be, obviously it's an inequality, so it's a range. Make sure that that's what shows up towards the end, okay? All right, so now, again, and problem, therefore, what do we set up? Sandwich, okay? So x, whoa, not that. X minus 15 less than or equal to 5, but greater than or equal to what? -5. Good. Okay, we add 15 to all three sides. We're going to end up with x is less than or equal to 20, greater than or equal to 10. Okay. Does that make sense? Yes? No? Thumbs up, thumbs down, thumb to the side. Okay, alright. Okay. Okay, I'm going to have you guys try 4, 5, and 6. Okay. Try it on your own. I'll come around, I'll help out. And then we'll go over it together. We'll review.